Hi, my name is Ed Masterson. This is CSC480, homework 2. First thing I do, I start and I ask for the number of plies. I'll start with 1. Then I ask for the column. So my strategy here is to stay in the middle. If the column's full and I enter that column, it says column full, choose another one. So as you see, the computer is also trying to stay in the middle. Now I can go I'll start this up again and do multiple plies. I'll do 2 this time. So as you can see, the computer doesn't go for the middle here. It doesn't start going for the middle until later in the game. Now if I do a higher ply, like 4, the game is a little bit slower, but it still goes. It's 4, 1, 2. See, there's a kind of a pause here at 4 plies, but still works. Still manageable. As far as the game board goes, my display board class, there is the display board itself is just a 2-dimensional array, rows and columns. I do 1s for white, 2s in for black. As far as modeling moves, I have the main game loop here. You come into the game loop, ask the computer, or ask the human to enter a column. Then once it knows calculates what the array, the board is supposed to look like, sends that into the successor function, and that returns whatever move the computer recommends after doing all the calculations. And so in this display recalc board, you enter the move essentially by the computer. As far as scoring goes, I calculate black score. I go from top left to bottom right, and I look for all the so this is black, so all the 2s that are together, 1s to the right and 1s that are below. So, and I add +2 if that is the situation, and then I check for the diagonals and add 1 point. So then I do, that's black, and then I do white separately. Here's calculating white score, same thing. Look for 1s to the right and below it, and then I check for the diagonals to add 1 point. As far as minimax goes, this is basically the successor function. Node comes in here with the number of plies and the current level, which starts at 1. Create all the nodes, set all the pointers for the parents, set all the pointers for the children nodes. Then, so for each column, so this is starting with column 0, but I calculate the possible moves, and then I take the black minus white score and give it to that node, and then I percolate it up in this right here. So if the parent alpha is less than the current alpha node, I send it up. So then I do that for each individual column. Then at the end, after the final 8th final column, comes in here. If it's a leaf node, then it figures out which has the highest, pushes it up to the parent alpha. If it's a min, then it pushes the beta up. And then if you're not at a leaf node, just pushes the alpha up here and pushes the beta up. These are non-leaf nodes. And how did I implement the alpha beta pruning? That is also in the columns as well. So if you come in here, here's my alpha beta pruning. If the parent alpha is greater than or equal to the S node's beta, or if the S node's beta is less than or equal to the S node's alpha, S node's parent's beta, sorry, less than or equal to the S node's alpha, then you just cut the node off and set it to null. Thank you.